अच्छा ये हम कर रहे थे थोड़ा सा कि what we were doing was कि balancing redox reactions, right? तो इसको हटा देते हैं. अच्छा, balancing redox reactions. So क्या था, number of electrons gain and loss, they have to be equal. So starting with easy equations, then we'll move towards more difficult equations. कि if I have, ये हमने कल किया था, if I have zinc goes from 0 to +2, focus on this reaction, zinc going from 0 to +2, so that means it loses 2 electrons, right? And silver ions goes from +1 to 0, so that means it gains 1 electron, right? So remember this, that electrons gain and loss, they have to be equal. So इसको मैं 1 से multiply करूंगा, and I'm going to multiply this by 2. So the silver should be multiplied by 2, and the zinc will be multiplied by 1, and now it's a balanced redox reaction because the number of electrons gained and lost are equal. ये clear है? ये वाली बात. Over clear है? Haseeb, Shan.
Yes, sir.
Similarly, you've got एक और कर लेते हैं. Al goes from 0 to +3, right? So that means it lost 3 electrons, right? और Fe जो है ना वो +2 to 0 गया. That's a gain of 2 electrons, right? So it gains 2 electrons. So the number of electrons gained and lost have to be equal. So I'm going to multiply this by 2, and I'm going to multiply this by 3. So I should have 3 Fe's, and I should have 2 aluminiums. So everything would now be balanced. तो सब कुछ balance हो जाएगा, ठीक है? So remember, redox equation, you have to balance the number of electrons gained and lost. They have to be made equal when you try to balance them. So यहाँ पे I'm going to try and do more difficult equations now, ठीक है? For example, this equation over here. ये पिछला तो clear है ना, electrons gained and lost, they have to be made equal at all cost. As starting with this equation, I'm going to try and balance this equation. Remember, redox equations are very hard to balance. I mean, they're impossible to balance in the normal way. You have to make the number of electrons gained and lost equal. So starting with, now how do you, if you don't know what the oxidation state is, if I don't know what is happening to Cr, so I won't be able to tell whether it's gaining electrons or losing electrons. So the first part is, okay, I need to figure out the oxidation state. So I'm going to start with Cr2O7, right? And Cr2O7 is 2 minus. Cr का कुछ नहीं पता, so that's X. And there are 2 of them, so that's 2X. Oxygen is -2, and there's 7 of them. And they should all add up to be equal to the total charge, which is -2 in this case. So if I solve this, it will come out to be, X will come out to be equal to, the equal to solve, it's going to come out to be +6. So that means this Cr over here is +6. Here, that's +6. Oxygen was -2. As a pair, I've got HNO2, so I don't know what HNO2 is, so I'm going to try and solve HNO2. So H I know is +1. N I'm not sure, that's X, and oxygen is -2, and there are 2 of them, so that's -2 times 2. And it's a neutral molecule, so everything should add up to be equal to 0. So X can solve for it, it's going to come out to be equal to +3. Okay? So that means N over here is +3, right? O is -2 and H is +1. H is +1, so it's obviously +1. So you need oxidation states, that's the first thing. As a Cr is +3, so it is +3 then. As a यहाँ पे you've got NO3 -1, so I don't know what NO3 -1 is, so I'm going to try and find that out. Okay, I've got NO3 -1. So N is X, O is -2, and that's 3 of them, and they should all add up to be equal to, -1. So x की जो value है, that's going to come out to be +5 in this case. So that means n over here is +5, O is -2, and H is +1, O is -2. ठीक है? Remember, H and O are mostly +1 and -2. ये clear है कि the first thing in it, when you're trying to balance is you have to figure out the oxidation states. Is that clear? अच्छा, अब मुझे बताओ कि somebody tell me कि who's getting reduced and who's getting oxidized in the whole equation. काम वही करना है, the one that we did just now. ठीक है, now we have to do that. So who's getting reduced in this whole equation? ठीक है, so it's CR. हाँ ठीक है, CR is getting reduced, and it goes from +6 all the way to +3. So that means it has gained 3 electrons, right? Achha, when I talk about this, I'm not talking about 2 CRs. I'm talking about just 1 CR. वो बाद में balancing करेंगे. We'll try and figure that out later on. But at the moment, I'm just talking about 1 CR. That's and N is oxidized. Okay, that's also true. N goes from +3 to +5. So that means N lost 2 electrons, right? Achha, so first thing when you're balancing redox reactions, balance the electrons. तो इसको कैसे मल्टीप्लाई करेंगे? I'm going to multiply this by 2. Circle that. ठीक है, I'm going to multiply it by 2. और इसको the other one, I'm going to multiply that by 3. So that means I should have 2 CRs. So then the number, and I should have 3 nitrogens. Then the number of electrons gained and lost would be equal. So I'm going to do just that. I should have 2 CRs. So if you look over here, so I already have 2 CRs, so I don't have to do anything. So I should have 2 CRs over here as well. So ये हटाओ तो क्या it is 2 CRs, right? अच्छा, n, how many n's should I have? I should have 3 n's. So this should be multiplied by 3. Get out 3. This should be multiplied by 3 as well. So get rid of that. That's 3, right? And the final thing is, so I've done this. I've balanced the number of electrons gained and lost. Okay, so I've balanced that. So the things that I did not balance, now I'm going to focus on this. This is the only thing that's not been balanced. So I just need to balance it the old-fashioned way, which is that get the oxygens, and that's 7. Plus there are 6 over here, so that's a total of 13 oxygens. 9 यहाँ पे, so there should be 4 oxygens over here. So water will be 4. So how many hydrogens would you have? That's 8 hydrogens over here. So 3 यहाँ पे, so there should be 5 H over here. So what is left is just balance the conventional way. The first thing is you balance the number of electrons gained and lost. Once you've done that, then just balance the rest of the atoms in the normal conventional way. Is this clear? This balancing clear? Is this clear? Shan, Umar, see. Clear? Can you clear? So I'm going to do another one. Let's go copy. So I'm going to do this one, and we're going to try. Remember, this is very important because once we start the chapter, every redox equation, it has to be a balanced equation. Okay? It has to be the electrons gained and lost. They've got to be equal. So let's start balancing this equation. इसकी मैं balancing हटा देता हूँ. So we're going to start balancing this one, and so let me get rid of the balancing first and try and calculate. ये पहले मैं हटा दूँ. So the 2 is gone. So let's assume that we don't know what this is, what these numbers are. Here, that's starting with the first one. Can you quickly calculate and tell me what is the oxidation state of I in IO3 -1? क्या होगा IO3 -1? and it is +5. Okay, so it's +5 and Ex -2 times 3, and that's equal to -1. So it's going to come out to be +5. O is obviously -2. So what is N over here in N2O? N2O, that's 2x -2, everything adds up to 0. So that is +1. And this is -2. Just remember that oxidation state is for one. The +1 mechanism, it's not for the two ends together, it's for just one end. Iodine is 0. Free neutral element, that's 0. NO, what's the oxidation state of N over here? Either care. What is N? So this one is +2, okay? -2 +2, it's obvious. -2, H is +1, O is -2. So who got, what happened to N? +1 to +2? Lost, got oxidized, right? Lost 1 electron. And what happened to I? +5 to 0, so that's reduction, right? Gain of electrons, that's gain of 5 electrons. So who gains, so that one gains 5 electrons. ये भी हो गया. The next part is, so the next part now. What do I multiply with what? Make the number of electrons gained and lost equal, right? So I'm going to multiply this by 5. Okay, so multiply this by 5 and multiply the other one by 1. Now there's an issue, and that issue is okay, if I try to do this, but 5 and 1, that would balance things out, right? But the only problem is it would be slightly inconvenient because we would have to get into fractions. Like, how can I make it 5n? I'm going to multiply it by what number? 3 by 2? 2.5 se karna padega na. So, and how can I make it 1 iodine? I would have to make it half iodine, right? Because 1 means I should have 1 iodine, right? So it's slightly inconvenient. So what I'm going to do is instead of multiplying it by 5 and 1, I just have to make the number of electrons gained and lost equal, right? They can be made equal by multiplying this by 10 and multiplying this by 2 as well, right? Even then it's going to be equal. I can easily make it 10. How can I make it 10? That's 5 and 2. ये clear है? ये बात समझ आइए ना कि why I did not multiply it by 5 and 1. Okay, 1 iodine, I would have to make it a fraction, which is, you don't want equations to be in fractions. Is that clear? So just to get rid of the fraction, what I did was 10 is easy. That's multiply this by 5. So this would be 5, right? And nitrogen's 10 karne, so this would be 10, right? So 10 nitrogens here, 10 nitrogens over here. So that's 10 nitrogens and 2 iodines. That's so this would be 2, and there are 2 iodines already over here. So this part is now balanced. Is this part clear? और बाकी फिर H और O की बारी आ जाती है. So you just have to get rid. I mean, do it the old-fashioned way. Like you have to balance H and O. So how many O's do you have? You've got 6 oxygens? 5, 11 oxygens. So you got 10 oxygens, you need 1 oxygen over here. So that's just 1 water molecule. And hydrogens, you can balance that. That's so there's 2 hydrogens over here, there's nothing over here. So this is going to be 2H plus 1. I said, but what if we write in fractions? There's nothing wrong with writing in fractions. The only problem is that preferably equations should be whole numbers. I mean, it's very inconvenient to balance equations and fractions. Like if I do this one, I mean, I don't like balancing equations. Like I've got, let's say I've got Na reacting with O2 and it's forming Na2O, right? So let's say I have this equation. Now I would prefer whole numbers, right? But so there's one Na, I will make it half. And that would make it half oxygen. So this would be 1/4. So that's very inconvenient. I mean, I don't like balancing. I mean, it's plus just remember whole number ratios. Equations are like a cooking recipe, and it's preferred that you have a whole number ratio. Okay, fractions are not preferred, although there's nothing wrong with it. Okay, confusion again, you'll get things wrong. I'll try and do another one. Just one. Let's do this one. ये वाली कर लेते हैं. अच्छा, so let's now this one. What happens over here? Okay. I said get rid of the 3s and 8s, etc. So I can make it. Wait a second. So now this one. So we have everything with us now, and what's iodine over here? First one, oxidation state of I in IO4 -1. क्या होगा? What is the oxidation state here?
+7.
This one is +7. O -2. What's pH3? That's -3. I is -1, so it is -1. P4 element neutral, that's 0. +1 and -2. ठीक है, सारों का पता लग गया. So अब आ जाओ इस पे. How many electrons are gained by iodine? Okay, what's the number? Gained by iodine, that's 8. Okay. So 8 electrons are gained. And vice versa, gain diya na tha, theek hai, that's reduction. And phosphorus goes from -3 to 0, so that's a loss of 3 electrons. So I need to make them equal. So what I'm going to do is I'm going to multiply this by 8 and this other one by 3. Okay, I should have 24 electrons gained, 24 electrons lost. So 3 and 8, right? So 3 iodines. So this over here should be 3. 3 iodines over on the other side as well. And I should have 8 phosphoruses. So 8 PH3s and 8. So I just need to multiply this by 2, right? To make it 8. So this is balanced, and I just need to balance the water now, which is how many hydrogens? That's 8 into 3, 24, 8. So that's going to be 12. Okay, that's going to be 12 H2Os. Oxygens are automatically balanced. That's 12 oxygens. Clear? अच्छा, एक और खाली, ठीक है? I just want to practice one more, which is which you already know of, hopefully. That's a disproportionation reaction. Okay, in a disproportionation reaction, I say in a disproportionation reaction, the same element gets oxidized and also reduced. And reduced. So what happens over here? I'll just do an example. Like if I have Cl2 reacting with NaOH, ठीक है, ये वो reaction है, hot concentrated NaOH. So NaCl is formed, NaClO3 is formed. Plus H2O. So I want to balance this equation. So quickly, we're going to do the same thing. So Cl over here is 0. So it's got an oxidation state of 0. Cl over here is -1. And Cl over here is +5. You can try and calculate this. This is +1, this is X, this is -2 times 3. So nothing else is changing oxidation state. O is -2, O is -2, N is +1, H is +1, H is +1. Everything else remains the same. It's only Cl that gets oxidized, and it also gets reduced at the same time. So you've got this reaction. Cl is the one that goes from 0 to -1. So that means it has gained 1 electron. And Cl goes from 0 all the way to +5. So that means it has lost a total of 5 electrons. So what I just need to do is, okay, I would have to multiply the first one by 5 and the second one by 1. So there should be 1 Cl that should be turning into this, so that you already have 1 Cl. But there should be 5 Cls that should be turning into Cl -1. So this is going to come out to be 5. Or wo jo hoga na, that's going to be 1. So the ratio would be 5:1. Starting point is the same. So that's 5 Cls and 1 Cl on that side. So that's a total of 6 Cls. So this would be 3 Cl2s. Start the way ki jagah se hue the na, they had the same starting point. So so 5 Cls turning into this, one of them turning into this, 5 turning into -1, one of them turning into +5. So in total you had 6 Cls. They all started at this point. So that's 3 Cl2. Baki Na kar lo, balance the rest. So we've balanced the redox part. Now you can balance the atoms. 5 Na plus 1 Na, that's 6 Na. So you got 6 NaOH. Acha 6 H honge, so there's going to be 3 H2Os on the other side. Okay? So is this clear? Disproportionation, Shan? Umar, Steve, clear?
Yes, sir.
But see, yes, I'll send you some lectures on this. That's pretty much it. This is what you did in AS. So we're going to start in the next class with A2. Okay? Just remember, you'll have a lot of redox equations. What you're going to study is, till now what you have studied is, the equation was already made for you. This was already given to you, that Cl would do this thing. All these equations were already known to you. You never made a redox equation. Now in A2, what you'll study is, you'll study how to make a redox equation. Like if I tell you, इससे पहले ना, all equations were already given to you. They were already made for you. So if I tell you that Pb4 plus reacts with Sn2 plus, so you're going to make this equation now. Okay, that's the difference. That's what you're going to learn. Yeah. What will Pb4 plus turn into? You'll answer that question. Maybe it's going to turn into Pb3 plus, maybe it's going to turn into Pb2 plus, maybe it's going to turn into, so what's going to happen when you react these two together? What type of redox reaction will you have? So in A2, this is what you're going to study. You're going to learn how to actually construct a redox equation from scratch. Okay, you're going to figure out who's going to gain electrons. You're going to learn who's going to lose electrons. The equation will not be given to you. You'll make this equation on your own. Okay? So फिर next class में ना we'll start with that. ठीक है? चल ठीक है, continue करते हैं. फिर next class important है. We'll give an intro to this and you learn how to make these equations from scratch. चलें, okay everyone. Allah Hafiz. Monday, yes.